Hello everyone and welcome back to the next episode. In this episode we finally move our objects around. Now we can just add a force here. You can see the force is accumulated, but nothing's moving. We're gonna change this in this episode. And for this I'm gonna add a integration method here, and this will be the semi-implicit Euler method. In the next episode, I'm going to go through some more integration methods. Um, but yeah, that's for the next episode, and I'm also going to explain the difference between those. For this episode, we just want to see something moving, and for this, I'm going to use the semi-implicit order. And with this one, we just basically converting the force, as I said earlier, to a delta position. We can do this by creating a new variable. We can, I'm going to call it acceleration. And here I'm going to convert the force in the force accumulator to acceleration. You already can see I'm going to use invert mass. We don't need to do a division. We can just multiply it and that's it. Then we can get a velocity out of the acceleration. And here I'm going to add the current velocity with a new velocity from the acceleration. So I'm going to say this dot velocity with the acceleration. And here we need to convert the acceleration first to a velocity. And we can do that by multiplying the acceleration with the current delta time. Then we have a delta velocity. And then we can say a delta position. Why delta? Well, it's an offset. It's not a final position. We're gonna set the polygon. It is an offset basically. Earlier we moved our shape by 5 pixels, for example. Every time I pressed the button, the shape was moving by 5 pixels. This is like the same, but here it will have a different amount depending on the acceleration and depending on the current force it has. Also, which velocity will be the final velocity. Depending on that, we're gonna move it not by 5, but maybe, well, maybe by 5, but maybe by 10. Depends on which force we have, alright? Okay, so, and now we can say the delta position is again scale. We need to convert this dot velocity with the delta time. And then we can finally say this dot shape, or actually we can say also this dot get shape, but I'm gonna say here this dot shape dot move with this dot delta position. Actually, I'm gonna say not this dot delta position. I'm gonna say let delta position. All right. Yeah, and of course I need to change this one here too. Okay. I think that's okay, yeah, and we also need to set the force accumulator to a 0 vector. There we go. And I think that's it for this episode. Let's check if it's working. So let's jump back to the browser, refresh, and let's press the D button. There we go. You can see nothing is working. Oh, well, actually, our velocity changes, actually. It's just not that much. So we need to press it longer. And we can actually see something's happening. We are changing the velocity of our circle. Cool. Yeah, well, it's not that impressive. um, so I'm gonna change the force in um, in the simulation class a bit higher to, let's say, 100. Let's try this again. Okay, now it's changing a lot faster. I can change here and more. I can add here more force. There we go. Yeah, it's working. Awesome. All right, then. That's for this episode. Um, yeah, have a nice day and see you hopefully in the next one. Bye.